Hello, Internet!
Hi, Internet. Thanks. Welcome back to EXAG. So this is our last sort of set of sessions for the workshop. These are our demo presentations. So we're going to be having six presentations on short demos, and then we're going to have a coffee break, and people can set up demos during that time, and then demos will be set up. Everybody can interact with them, just chat, have a good time. I believe we get kicked out of this room around 5, so we have till then. Is everything okay on stream?
Yeah, no, I'm just trying to remember which one of these presentations is which.
Okay. So again, these presentations are going to be pretty short, so if you have any really extended questions for any of the presentations, maybe save them for the actual session, the interactable session later. 1 or 2 sort of general questions for the benefit of the stream would be welcome if you have any.
All right.
And I think start
with that, if we could have our first speaker.
Okay, hi. I'm Ethan Robinson from Northwestern. I am going to talk about sort of using industry tech for research purposes. Which sort of immediately begs the question, like, why would we bother doing that? Computer scientists kind of like to do their own stunts. We like to make our own stuff. And so part of that is actually we kind of like to make our own stuff almost to like a little bit of an arrogant extent. And when we're making games, we'll often start from scratch when that's not always necessary. And then there's actually another really important problem to solve, is that research software has an annoying tendency to not be quite shippable. Accessibility is kind of a joke, usually. I mean, you don't have the time or the energy or the resources to really put the sort of features in that might make your product, your research accessible. Performance isn't always a priority. Sometimes it is. Sometimes you're making something with the express purpose of being performant, but usually when you make stuff, performance kind of comes second or third. Also, cross-platform capability tends to be accidental. If you make your games in Unity, congratulations, it's cross-platform. If you make your games in, Excel macros, among other problems you might have, you're not really going to be able to ship that to a lot of different people. This system is also kind of a proving grounds for an experimental language that my advisor Ian Horswell is working on. We'll talk about Bottle in a little bit. I also like simulation games. This was a bit of a selfish project where I made a thing so I could make myself other cool things. And also a really important point, art is really hard. So I've been programming for about 4 years, and I've been making games for about 2. I have not gotten appreciably better at art or music or writing copy or anything, despite hanging out with a bunch of people who do that stuff all the time. Most of the time, when we make research projects, they don't have very good art. We get our sprites from places like Open Game Art or DeviantArt. If we have background music, which usually we don't, it's kind of like a loop thing that was available for free. Our UI tends to be in like 18-point white on black Arial. Like, there's not a lot of design. So this is a very interesting slide. I was like, okay, I'll put an example of really crappy research projects with bad UI and art, and then I realized I couldn't do that without being super insulting. And I was like, okay, well, I'll put my own stuff up. And I was like, well, I can't put my own stuff up because this is the first thing I've made, and the whole point of this project is that it's a counterexample. So just imagine, my most egregious artwork, which is truly bad, up here. And so, all right, let's talk about the actual system. So the AI sandbox, which if you want to be super hoity-toity, you might call it like a system for writing custom social simulation, like AI controllers or something. We just call it the sandbox. It's a lot shorter and it is more realistic. It's built on top of Project Highrise, which is a strategy simulation game from SomaSim. I work at SomaSim. I work with Rob Zubek. It's kind of a fishbowl sort of game. You set up this skyscraper and you put your NPCs there and they go around and they live their little lives and you can watch them and you can like manipulate them because you are their overlord. This isn't supposed to be a plug for the game, but I guess it kind of turned into one, so sorry. Okay, Bottle. So Ian hacked together this logic programming language called Bottle. The hope is to bridge the gap between academic programmers who love things like logic and declarative programming languages, and industry, which historically has not used them for very many things. It's mostly stack-based. So it's substantially more performant than a lot of the other things, while also being not quite as heavyweight as most of like everyone's favorite answer set programming framework. It's very similar to Prolog. It's got some minor syntactic differences. It's implemented in C# because it was specifically designed to be used in Unity 3D. It is a thing that you can get if you wanted to. You could download it yourself and drop it into your project. It's still super experimental though, so like just be warned. Okay, so this is a very confusing diagram, and the idea is that I'm going to give you like a really high-level description of the architecture of the system, and if you're actually remotely interested, we can talk about it later. But broadly, the idea is that Project Highrise has a really complicated architecture. It's got lots of moving parts. Among them is a schedule manager for the NPCs, which they say tells them what to do and when to do it. That got ripped out for this project and replaced with a bottle manager. Now whenever the NPCs need something to do, they say, hey, bottle manager, what do I do? And the bottle manager says, okay, well, let me consult the bottle knowledge base. It asks the knowledge base, what should this NPC do? And then it passes that information back. Also, on every in-game tick, the bottle manager says, hey, bottle knowledge base, is there any general stuff you want to do? So do you want to change the weather? Do you want to change the, if you wanted to simulate an economy or something, do you want to change the in-game value of things? So general stuff, and there's also NPC-specific stuff that gets handled as needed. Like I said, it's super confusing, but if you actually care about it, I'm glad to talk about it at length. It's just way too much information for a 10-minute talk. Okay, so how did we do? The good news is that it does work. You can write custom AI controller code for it, and the NPCs will do what you want, so that's neat. You have all the lovely expressiveness of declarative logic programming, and for those of you who have used declarative languages before, you know that that's actually kind of a lot. Also, logic programming, declarative programming is really good for like this sort of stuff, for kind of making general claims, general rules about the way that the world should work, and having the world act on them. The bad stuff. So it's got a pretty limited use case. Like if you don't like social simulations, this sandbox is going to be pretty much useless for you. I like social simulations, and like I said, I kind of made this for myself. So if you like these things, great. If you don't, I'm sorry. Also, if you don't know Bottle or Prolog or other declarative languages, in order to use this, you have to learn a declarative language, which is like not very fun. Once you've learned it, you're like, I don't understand what's hard. But then if you think back to when you were first learning it, you're like, what the hell is going on? Okay, and kind of the like embarrassing little tidbits. So obviously, it's not as performant as the vanilla game. The cool thing about Project Highrise is that Rob did a really good job architecturing it, so you can run like 1,000 NPCs and still get 60 FPS on a like moderate spec machine. This game, you probably cap out about 200 before you start to see issues. That's partially because it was designed to work, not to be super performant. So there's kind of irony that I was like, oh, research stuff isn't performant, but here we are. Also, it's easy to write bottle code, or in particular, it's easy to write controller code that doesn't perform well and not know what's going on. Because of how experimental this is and how experimental Bottle is, it's kind of lacking features. The good news is that if I want features, or if y'all want to use this and y'all want features, you can just email me directly and they will get implemented because it's a very small user case. Anyway, okay, so that's kind of the embarrassing stuff. Ostensible future work in addition to like polishing off all of those rough spots. It'd be cool to have a library of useful functions. Currently, if you want to do anything clever, you kind of need intimate knowledge of Project Highrise codebase, which basically means you either need to be me or Rob. An explicit representation of events. Currently, things like someone saying hello to you, or you catch on fire, or you run out of milk, like all these quotidian things that happen on a regular basis, there's not an explicit representation of events. You can roll your own, and it's really easy, but it doesn't have like native support, so those things are kind of a gimme, but aren't currently implemented. And then like hopefully applications in the humanities. There are a couple of labs at Northwestern that do like CS plus like psychology research, and they're very interested in the idea of like, could we use this to quickly prototype broad models of the human psyche? And so hopefully that's a possible thing. But yeah, that's the system like in 7 minutes. Hopefully that was helpful. That's all I've got.
guess we're not sticking around for questions.
I mean, I can. I just didn't look like anyone had any questions.
Yeah.
Go. Sorry. What's your question?
Well, could you put one of those code snippets up on the slide and explain what is happening in one of them?
Sure. Okay. So, can you read this? It's okay if you.
Enough, go ahead.
Okay. Oh.
Well,
The glare is kind of bad.
Okay.
it's
Well.
a screenshot, so it's not easy.
Yeah, I unfortunately don't have any like live stuff. Okay, so director decision, which is the sort of thing that I talked about, gets called every in-game tick. This arrow means like run this chunk. This chunk is ignore, and then it calls this predicate choose movers. Choose movers has some body of code that gets run, and the thing is with like declarative languages is when you run a body of code, you start here, you say, does this thing return true? Okay, does this thing return true? And you go until you reach the end, where if anything fails at any point, you bail out. Meaning that anything imperative, though, that happens here doesn't necessarily get undone, depending on how you've structured things.
And I see there's some statements with bang,
Those are imperative ones. Actually, director decision and make decision are both imperative, but that was before Ian and I agreed on the bang naming convention, and so they don't have bang, but these are imperative. This might be a better one. This says, like, for all things that you can unify X in the EL database for homes, call this predicate on X with this argument. If you like declarative languages or you're curious, I will gladly talk about it.
Thank you for sending me that.
Yeah. Cool. Other questions? All right. Cool. Thank you.
So who's up next? So where's my mouse? So you are that one. Cool. Yep.
Thank you. Sorry. Hi, my name is Javier Torres, and I will be presenting the action framework proposal for unification. So we have seen a lot of different formalisms for agent control. We have seen behavior trees, FSMs, planners, but how different are they in the end? Can we find some kind of common formalism among them to describe them in a homogeneous way? So a bit of introduction. In last GDC, Bobby Angelov at the AI Arborist session commented on a new idea, hierarchical finite state machine behavior tree hybrid. And the rationale for that was that a behavior tree, if you look at it, is a kind of solution to some badly specified contingent planning problem. So it's, for example, it's badly suited to continuously running actions. So he proposed a hierarchical finite state machine in which you could find behavior trees that were run at different stages. So, but do we really need separate formalisms for that? It seems that we have silos, FSMs, we have behavior trees, planners. Could we use something in common? So if you take a look at behavior trees, for example, the missing piece here is recursion. You have a graphical notation. It's a bit hard to fit recursive definitions in it. And apart from that, there are some substantial ideas that could be incorporated, for example, from Matthias and Stern work in AIIDE that have been lost in industry in the way, like behaviors being annotated with goals or preconditions to be able to assert some invariance on the behavior trees or their reflection in the behavior trees themselves. So what I'm proposing is to get some concepts from process calculus and take them to some variation of behavior trees, which I call action trees for lack of a better name, frankly, that can be used to implement FSMs, BTs, HTNs, and let's say other weird constructs, which frankly I'm not really confident they're useful, but you'll help me with that. So basically what you have here is a different view on a typical behavior tree. In the runtime view, you have two active nodes, the parent sequence, and then the moving child, which is behavior. You can deploy detectors and behaviors, so that detectors act on the game state at each tick and send events, conditions on the game state upwards into the tree. So, for example, the move A behavior node can send an event, in this case a success event, when we had reached position A. We can also deploy behaviors that run on the game state and produce some action which is not directly executed, but that can compete with other actions using mechanisms similar in utility mechanisms and utility systems. For example, we may have cover and fire actions available. We have them active, but at each point in time we decide which is the best action to take. So when we receive this success event, when we reach point A, the sequence takes its associated state, the list of nodes, take the next node in the list, which is basically move to B, and then replaces it in the tree of current nodes. It deploys another behavior, run to B, another detector as well, which is not running in this stage. And then we have, for example, other compete behaviors, and in this example, we might advance our position a bit more towards B. By having process nodes sending events from the leaf nodes upwards, we could have FSMs in which we have nodes with no associated state, rather apart from their identities. So we would have a patrol sort of behavior tree which returns a light event when we find a source of light. And when the patrol process node receives this event, it turns itself into an investigate node, again with no associated state, spawning another tree, investigate BT. We might find something in which we might get a special event, but in this case we just get a timer off because we haven't found anything. And in this case this action reaches an ended state and we end up in nothing and reporting an all clear event upwards. A BT sequence is pretty much the same thing. We also have a process and events. We have the success and failure events, and probably you all know about this. When we have a failure in an action, even though we have pending actions, then we reach an end state, report failure upwards, and then we finish. And when we get a success event with no pending actions, again, we report success upwards, and we get nothing. But then things can get weirder. We can implement also some kind of HTM in which we have some special node called default, which can accept two kinds of events. In this branch, these are two active nodes at the same time. These are both running. One of them is a classical behavior tree, and this represents some kind of default action that we take until we get something better. So in the usual implementation, if we get a success here, then we reach an end state. With the default plan we have, then we have managed to do something that we want to do. But on the other hand, the planner may find another plan that is more useful or more appropriate for the situation at hand. So in this case, this running behavior tree is discarded, all their behaviors and detectors are discarded, and this event carries a plan, which is basically another tree that has been created on the fly and is attached instead of this process. This process turns itself into another process, which was the output of a plan. And in this plan, you could do you could repeat the process in several stages and carry out some kind of HTML-like process, or return a single sequence if you use classical planning, or return the usual and/or trees or sequence and selection if you want to do contingent planning. So it's a bit of plug and play. Yesterday I tried to say, okay, we've all heard a lot about behavior trees, so try to come up with a different example that doesn't look at least a bit different. So we might have I came up with a crazy idea, probably totally useless. The purging move sequence. What is this exactly? It's like a sequence, but instead of actions, it has waypoints. So we consume waypoints in the same way as a sequence consumes actions. So we have a current action. We move to A. When we finish that, we get the next waypoint B, and we move to B, and then we move to C, and the report a success. But in the meantime, if someone else, for example, takes the loot or their enemies that are being killed, there's a purger here that keeps track of waypoints and says, remove from the waypoints this or that, without resorting to an external blackboard, for example. So in this case, we have the third location, location C, and it says, okay, remove it from your waypoints, and you're finished when you go to B. So we are still moving towards A. We will move towards B, but we have already removed location C because we don't see it as important. So, is this even new? I think that having dynamically generated action trees has possibilities. I don't know if any of those possibilities can be implemented with current technology, but I think that the use of very tightly coupled elements in different silos it's detrimental to AI design and may make some constructs really awkward to implement. So basically, I try to provide some kind of common formalism to these ideas and some more. So thank you all for your attention, and any questions are welcome. One question.
So, I think it was a really interesting talk. I'm wondering how easy it is to author these action trees.
Yeah, that's a good question. I mean, because normally in behavior trees you have the full, the fully unrolled, so to speak, specification. You can see what you are doing. But if you take a look at programming languages, you have the same with function calls in this case, and no one is complaining because it doesn't have the full layout of subroutine calls. And probably the best thing here to do would be to come up with automated tools to check that some invariants are in place. So I feed it some kind of event traces, and then I make sure that I reach the state I want to reach in the end. Especially if you have preconditions, which is not in this state. Thank you.
All right.
Thank you.
All right. Who's up next? Where's my mouse? Next we have... Yes, you.
Boop. Hey, thanks.
Yeah.
Hey, everybody. I am Matthew Gosdial from the Entertainment Intelligence Lab out of Georgia Tech. This is a demo entitled A General Level Design Editor for Co-Creative Level Design that I did with some folks at that lab. So, first point, and I've used emoji to be easily understood. So procedural content generation is this sort of framework that's come up a lot in the past 2 days, multiple times I would say, but I'll go ahead and redefine it because why not? The idea here is that we want to encode some design knowledge, whether that's in heuristics or rules or constraints, and we're going to use a generator of various different sorts to get some new content out of that. PCG-ML, or procedural content generation via machine learning, is this new hotness, thus the fire emoji, where instead what we're trying to do is we're going to learn some design knowledge or distribution over some possibilities of some designs from existing content examples, and then we're going to use that to generate some more. But there's this problem here, and I want to note that this slide represents the views of only me and not the views of my co-authors, so please don't come after anybody else with pitchforks. But there's not really a strong argument for who would want to use PCG-ML. Designers would have to implement many different, for most applications of PCG-ML, would have to author many different pieces of content already, and if they're doing that already, why not just put it directly in the game? For those of you who are familiar with PCG and are capable of using it, that's a much stronger tool than PCG-ML is with lots more control. So not quite sure what you do with this thing, even though it's cool. Separate thread. Creativity is also pretty cool. The idea here is that we're going to have AI and humans working together to create something, whether that's a drawing, a piece of music, a recipe, a game level. So there's a problem here that we don't know a lot about what AI human designers would prefer in what contexts. People are very excited about the idea of AI helping humans out, but we don't really know how they should do that or what kind of approaches work well. Introduce Morai Maker, which is a terrible pun and pronounced More AI Maker, like Mario Maker. Yeah, I've had to explain it every time it gets groans, but I keep going. It looks a little bit like this. It's this level design editor interface, but there's this cool button down here at the bottom right that says end turn. And the idea here is that the player can make additions and deletions to some level sort of canvas, sort of like Mario Maker. And but when at any point can prompt the AI and said, hey AI, I would like you to make some additions to this level now. But notably, this AI level editor is server side. So anything that can plug into a server, we can test out. So the idea here is we're going to try to do a PCGML co-creativity study. Where we're going to try to get novice and expert designers, and we're going to have them create 3 levels with 3 different AI techniques. Of many, many AI techniques, I've currently got a small legion of undergrads who are implementing AI techniques. And then we're going to rank these AI partners, or have the designers rank these AI partners based on things like how frustrating, how helpful, how valuable, how creative, et cetera, et cetera, et cetera, and ask some demographic questions. And the idea is that we're going to try to make the output from this suitably anonymized, open to everybody as a resource to hopefully inspire future research. So there's going to be a demo. I'd like you to come use it. We have, well, okay, so my undergrads broke it, so don't pay attention to this one, but we've got my weird video, AI, grammar, whatever nonsense. But if you can give us feedback on UI, things that we might want to ask, study design, AI techniques that we should check out, etc., we'd love to hear some feedback. We want to make sure that this is going to end up with being knowledge that's useful to the whole community. So as much of people as we can get feedback, we'd love it. And yeah, that's about it. So quick summary in case you dozed off or I was too all over the place. We have an intelligent level editor that we want to use to investigate the applications of PCGML, that's procedural content generation through machine learning, to co-creativity. Please give us feedback on the study to investigate the above. And thanks. I don't know if there's any questions. Cool. Yeah, feel free to come by, I guess, during the demo period.
All right. Just churn on through. Who is next? It is, yes, this one. Cool. Here we go.
Hey. Hi, I'm Brandon, and I'm going to talk about ProcDefense, which is a pretty terrible name for a very boring-looking game. So, we're off to a good start. ProcDefense is an arcade-style game that the player has very limited input in. They can move their paddle, shown in yellow here, about a central core that they're trying to defend from a nefarious cluster of projectiles. This is the extent of the game. There's a link here if you want to go play it. We'll play it at the end of whenever I stop rambling. So, ProcDefense exists because I am bad at video games. That's really the long and the short of it. I like to play competitive games, and I am really bad at getting better at them. So, I watch a lot of videos of people reviewing other people's gameplay, and have noticed a few things that are kind of problematic. So, first of all, people who are qualified to do reviews are few and far between, which means they're inundated with lots of requests and can't possibly service them all or anywhere close to that. Number 2 is that they can't always give you the most intelligent advice about learning to play a game. They know how they play it, they can possibly identify problems in your gameplay, but they may not be able to tell you how to fix yourself in order to get better. So, I would like to explore building a system that can actually do this. So ProcDefense is a first step at exploring the or giving us a ground floor to begin to build AI and test in a very controlled way and compare how good different techniques are at generating skill improvements in players. All right, so ProcDefense is a research tool. That's part of why it looks so boring, because the IRB is not afraid of basic shapes, which is really awesome. So it is built to be very simple, very controllable, and very repeatable. Let's see. And so the problem that it's trying to address in training people is not unique to us. It's not unique to games. This is something that people have been trying to do forever. School, training for military, and in more recent times, flight simulators and surgery, augmented reality simulators are doing all this same thing. What we have an advantage in the games domain is that we have almost no domain transfer. We are playing the thing that we want to play already. Right here, we can adjust it, we can control it completely because we have the programs that make those situations in the first place. So that makes this a little bit of a unique opportunity to examine different techniques for training. Let's see. So, I believe we had a good point at the first presenter that was, we all love to build new things as computer scientists, and maybe we shouldn't always do that. So, the question comes, why should we use this game in particular? Well, it has an extremely simple domain. We examined using something like MicroRTS or using an Infinite Mario or some other platformer, but even those domains are somewhat complicated and difficult to try to interpret player intention and things like that at face value. So what we did was scale back to, we have one way for players to input their directives. So they have one dimension that they can rotate their blocking paddle in, and then we can layer other mechanics on top of it. So this gives us the ability to record complete gameplay attractively, and then we can parse it and reason over it with AI systems that could operate in less than years. Like if we want to do a planner that analyzed intention or something like that over it. So this game also has the advantage of, well, one criticism that was given, and it seems pretty valid, is that there may not be enough of a strategic element in order to decide whether players are making good decisions. You could maybe get some feedback on how quickly they're moving toward the next thing to deflect or something like that. And so this actually gives us the opportunity to integrate disparate game mechanics into one place and stack layers of strategy one after another and test them independently on users. All right, so that gives us scalable strategic complexity. So that's ProcDefense, that's why we have it. What we're doing next is trying to build a model of what difficulty means. So we have all these parameters that we can control for a swarm of projectiles that we're generating and trying to deflect. And so if we try to vary too many and try to figure out what difficulty looks like in that space, it's problematic. So we maybe pick a couple and say, all right, well, we expect that score is probably going to go up as maybe size increases because it's easier to deflect things. And maybe if we vary speed at the same time, so we've got a two-dimensional plane that we're varying over, then we might see that scores drop off as speed decreases. But what we don't know is that this is actually going to be some linear combination. We just have no idea. There may be inflection points based on the size of the projectiles relative to the play area. Maybe they interact with each other and destroy each other before you can hit them, that kind of thing. So what we're doing right now is running a pilot study to determine what order of pairings of parameters provides a smooth difficulty increase curve. Once we have that in hand, we can start to evaluate different techniques for bringing players through levels of difficulty and trying to improve their skills. So that's where we are with ProcDefense. If you have any questions, please let me know. And thank you.
All right. Who we got next? Ah, yes. We have microbial art, which this one.
Okay.
Yeah, and also I have the video open down here. Do you want to do that first?
Okay.
Or?
No, I'll do the slides first.
Okay.
Yes. Okay, I'll ask you if I need help.
Cool, so your slides are over here.
Oh. Okay. I'm going to need help to play the video, then I ask you if I can't make it.
Totally.
Okay, thank you so much. So, hello everyone. So, I'm Leandro. I'm going to be presenting this demo, Microbial Art and Implicit Cooperation Musical Experience. So, basically, cooperation is a very common theme of studying multi-agent systems, but normally we assume that one agent is explicitly helping another to accomplish some common goal. And what we are exploring here now is this concept of implicit cooperation. The idea here is that one agent is helping another, but the agent is not aware of that. So this is an example that's very common in Brazil, where you may have a bus driver, and then a bicycle rider grabs the bus, and the bicycle rider uses that to be able to move around the city. So the bus driver is not aware of this bicycle rider, but even so, he's helping the bicycle rider to accomplish his objective. Although you should not try this yourself, but it's quite common in Brazil to see this situation. And our idea now is that we want to use that for music generation, for a human that's interacting with a computer system. But we want to do that in an implicit cooperation way. So the idea is that you have a human player that has some objective in the game, so the human is not worried about generating music, but by using the side effects of the human actions on that digital system, we want to merge some kind of new song through that interaction. So the overall context of this work is in the idea of art games. So the idea is that we want the video game to be some kind of new way for artistical expression. So we are seeing games here as an artistic media in the context of this work. And we are using some concepts from music theory. The main idea is that we think about music as repetition of patterns. And we also use the idea of chords throughout this work. And chords are sets of notes that we know from music theory that they sound beautifully when they are played together. But in this work right now, we are playing one note at a time. So instead of focusing on chords, we are focusing on arpeggios, which is exactly the same set of notes, but instead of playing all of them at the same time, we have to play one at a time in sequence. So basically, it is just an example. Chords, normally, you skip the next note, so we go in what we call in a sequence of thirds. So for example, C, E, G would be a chord in this sequence of thirds, always skipping the immediately next note. And we could play that in order. So C, E, G is an example of a chord, but we have many possible arpeggios if we change the order that these notes are being played. And if we have the usual musical scale of 7 notes, we can have all those variations of different arpeggios or different chords that, again, we know from music theory that they should sound beautifully when they are played together. And we also explore the concept of power chords. That's just like the normal, usual chords, but we skip the third. So we are going to play the fundamental note and then what we call the fifth. So exactly like this, but we skip the one in the middle. So the main idea of our work is that we are going to place musical blocks on the floor of the scenario of a digital game. And we can concatenate those blocks, so we can put them in sequence, so that we can cover the full scenario of the game. And as the agent, as the human is playing the game, is moving that floor, it has to step on those musical notes, and then they're going to be played as the human is moving around the game. But again, the human is not aware of it. He will be trying not to destroy enemies, collect items, and so on and so forth. So the main idea of our algorithm is that we can generate those musical blocks, and we generate in a way so that when we move in the vertical direction, we're going to be moving a progression of thirds, so that it will be likely that we can generate those chords. And when we move in the horizontal direction, we're going to be moving a progression of fifths, so that we're going to be likely to generate power chords. And we have a theoretical study of this algorithm And I don't have time to present it here, but we have a paper in the main AIIDE conference, so please check our paper. But in a high level, we can prove that if we have an odd number of notes, those musical blocks are always going to be complete. We're always going to have all notes in the set, and they're always going to be cyclic, so that we can always concatenate those. But if we have an even number of notes, we're always going to miss some notes of our set. So if we have a 4x4 set, we would be missing notes B and D. And we also show that if you do a random walk in those musical blocks, we have a higher probability of generating music than if we just randomly select notes from a set of notes. And in the paper, you can calculate the probabilities for each case, and then you can check the details later. And basically, we can also show that if you have a human being that's actually playing a game in those musical blocks, we're going to have an even higher probability of generating music than if we are just doing random walks in those musical blocks. But we need a strong assumption that humans are more likely to move in straight lines when they are playing a digital game than if they are following diagonals. So this is something that we still have to study a bit better. But you can think about humans playing a game, let's say, in a keyboard, so it's easier to go ahead or turn right or left than follow diagonal sequences. And we did an experiment with real human players playing these systems. And we studied two different systems, a random approach, where we just randomly pick notes from a set of notes, and a cooperative approach, where we are using our algorithm to generate music. So users are not aware of this. They are just playing a game, trying to collect items in a scenario, and they're going to play those two systems for 3 minutes each, basically. And then we did a survey to evaluate this work. So we asked whether the audio is arbitrary or interesting, if they would classify the output as music, if they think the experience is disturbing or pleasant, and so on. So this is our result with 10 human players. So overall, they tend to think that the audio of our system is more interesting when comparison with the random approach, but I could not distinguish the effect of the actions in the system when compared with just randomly picking notes. They also had a tendency to select our output as music in comparison with random, but they also felt that the audio of our system was more disturbing, which in this case is a kind of interesting result for contemporary art, because sometimes the object is not to have a pleasant experience, but having a disturbing experience can be actually more interesting. And now I want to show a video. You can guys also play the game after this. Can you help me put the video, please? Yeah, sorry.
Where's my mouse?
It's over there. Okay, so it's... Okay, thank you. Can we have audio?
Yeah.
Is it
muted? Okay, we definitely have some audio coming through. Here. Let me pause for a sec. Flip back. Got hit on mute. Here, sorry.
No problem. So this would be the user that is playing this game. He's just trying to collect those items that are scattered around this scenario. So he doesn't know what's going on, but every time he's moving, he's tapping on those musical blocks, and then the corresponding note is being played. So in the random approach, you would just randomly pick a note each time you're tapping a block. And in the what we call the cooperative approach, we are following our algorithm so that the music emerges through that experience. And after the coffee break, you'll be able to play it yourself, and then you can see how you feel about the songs that are being generated. But yeah, that's the basic idea. If you guys have any questions, maybe we can start asking while the video is being played. You can admire the song a little bit more. Yeah, so please come see our demo after the coffee break, then you can check it for yourself, how you feel about that experience. You guys have any questions? Okay, all right, so thank you very much for your attention.
What do we got next? Ah!
Yeah. Also, it's worth noting at this time we have one extremely late-breaking presentation that we'll be doing after all this.
All right. Hi, I'm Eric. This is going to be kind of like a status report. Kristen presented some work done with myself and Alex Hook at last year's EXAG on a programming model for representing like 2D boss designs. And by that, I mean, there we go. These kinds of like state machine based, physics heavy, like action game boss designs. And since then, we've developed technology to kind of like get a demo prototype working, and that's what we're here to present today. I'll show you a video of it and explain a little crash course on like how it works. We presented more detailed information about that at the most recent FDG. High level summary is that these bosses are like kind of typified by a lot of state, like the physical objects that make up these bosses, where they are, how fast they're moving, like integer counters, like how much health does the boss have, what's going on right now. And like state machine driven behavior. They're usually executing some kind of attack pattern where they're chasing the player, running in a circle, moving between these like a finite state machine style. And these are like a really challenging, what we want to do is generate them. And this is like a really challenging target for like existing PCG techniques. Like they mostly focus on static content, not these kind of complex dynamic behaviors. So we built one, and here's just a video of it in action. We focused on like a Mega Man-like thing, where the red one's the boss, and the blue one's the player, and the boss runs around executing like a finite state machine attack pattern, like either hopping around or shooting at you or running in place. And as you, and it does things like as you damage the boss, it'll like escalate, so it'll start shooting faster or jumping higher or doing more damage to you. And the way we built this system was through generative grammars, but a like sophisticated grammar like based around where the target's like a domain-specific programming language of bosses. That's the thing we presented last year at EXAG, and then what we've done since then is like target generating that. I'll like maybe regrettably show you an example of, I'm not going to explain the details of what this is, but like this is like what the program looks like, where you I can highlight the two parts I mentioned, the state. You generate all the bits and pieces of like what makes up the boss, what are the different parameters of the different parts of the behavior, and then like a graph that's a finite state machine representing the behavior. And so our domain-specific language lets you express all of these, and then we build both tree grammar and graph grammar rules to target that. And the important part of this work that like made it work is we also use properties of the programming language that the grammar can express to express design constraints. So like we generate programs that are guaranteed to be well-typed, and where all the variable references are guaranteed to like be well-formed, and we use this to express things like when you damage the boss, it'll escalate some aspect of its behavior by referencing like an arbitrary piece of like previously generated content. So I'll keep this short, and if you're interested to see more, you can come talk to me at the demo, and thank you.
Sweet. Okay. So finally we have our last demo presentation. Once I get it slipped over to the presentation screen. So yeah, we're just going to be restreaming a YouTube video. Hope no one minds. Yeah. I'm sure Google doesn't mind. I'm just waiting for the stream, I'll just wait for the stream to get taken down because you know, copyright claim us. Yeah.
All right, hello. My name is Mark Riddell, and things were so exciting that I decided to jump in at the last minute with my own demo. This is something that I've been working on in my spare time, but let me motivate the scene, okay? Did you know lots and lots of people are using neural nets to make art? People have made Pantone colors, people have made Dungeons and Dragons spells, people have run Shakespeare through neural nets, using generative adversarial networks to modify images, make new images, style netify the images to make everything look Picasso-like. this is really exciting. Really cool things to do, really powerful neural net tools. And then you sit down and you try to use them, and you spend like 18,000 hours data cleaning before you can ever even get your neural net up and running. And if you're not into scripting, if you're not into programming, this is a huge, huge problem. So even I hate it. So I decided that I was going to build a visual programming language that lets you set up neural nets, but mostly provides you with a lot of different modules that will data clean your text or your images or things like that, so that you can pipe it into your neural net and get something out. The idea is you can sit down in a very few minutes, do something as simple as get a neural net up and running. This is a superhero generator, superhero name generator that's being built right here. And you might think, okay, that's cool, but I still need data, right? Where am I going to get the data? Well, one of these modules, also, I parsed Wikipedia for you. So that's there. I provided modules that will let you strip things out of websites. There are generative adversarial networks, there are StyleNet networks, there are LSTMs. A whole bunch of your most standard neural networks are built into this system. And all you have to do is figure out which modules, almost like you're writing a computer program. You can drag things around, and then strange things happen at the very end of your demo. Is there a way for me to get
What do you want?
this thing back up again? Can I cancel
Yeah, here.
this thing down here?
Yeah, that'll go back to.
All right. So, if you want to know,
Here, I can navigate.
I just want you to scroll down here a little bit. Can you scroll?
So there's the mouse. Okay.
All right. So, the link is not there. Come see me for the link. Again, my name is Mark Riddell. The system is called easygen. Everything is on GitHub. I'm a professor. I work on this in my spare time. It breaks a lot. I just discovered my GANs don't work today. But I'll be demonstrating it. Hope to talk to you more about it. Thank you. It's there, so it's not there.
Yeah. All right, so unless there are any more literal last-minute breaking demos.
I can show something really goofy.
Okay, go on up.
Mostly because I tried to do this on Twitter, like when I built this thing, I was like, I should submit this to last minute EXAG.
So what do you
and
want?
Michael Cook said I should. So this is a bot that I made.
That's not going to show up
sorry.
there. I forgot to clear my browser history.
Ah, cool.
So I'm just like, let's not stream it.
Safe. Boop. All right, cool. I just wanted to present this thing because this is like, you know how I was talking about stuff can become inputs to other stuff? This is something that I made as a fan bot for a sort of poet, writer, internet person that I know named Jomini-san, who made a really good book this year that's about, it's like Shel Silverstein for graduate school anxiety, if that's a thing that you would like. So I made this fan bot for it, and what it does, I need to put up all this, oops. Oh, right, different laptop. So what it does is I scraped I downloaded all of the quick draw data. Is anybody not familiar with quick draw? So quick draw is this thing that Google released. It was a really cool idea. It was make a game for people to, the system gives you a noun like canoe, and you have to start drawing a canoe, and the neural network will try to guess what you're drawing. And so you try to, like usually in a couple of strokes, it can guess that you're drawing a canoe. And they saved all the data from this. So there's like, I think 5 million or so images for each of 250 nouns. I downloaded all that data. I wrote my first ever Python script to actually comb through that data and give me 5 examples of everything, because it turns out there's not a lot you can do with like 5 million of something, unless you're really into Python and machine learning. And then put it into a tracery grammar. And this tracery grammar then draws faces on stuff and does a tracery generated little dialogue from them. How do I go back? Oh, right, this is Twitter. So open it.
Yeah, I had to click like
right there. where is right click on? Okay.
Yeah. So left click is all the way over here. Right click.
Okay. Anyways, like you can go here. There's like some very this one was pretty good. So yeah, this was just a. This is by far my most successful Twitter bot, and I've made a lot of Twitter bots, so I figured I'd show it off. This is like the sort of interesting emergence you can get from very simple grammars using other people's much more sophisticated AI and user data. So thought I'd show
Yeah. Thank you. All right. Well, Kristen, do you want us to come up and say a few last words? With me, of course. Yeah, just wanted to say thank you all for coming out, making this iteration of EXAG, you know,
A lot of fun.
Yeah.
We really appreciate everyone here who is here, everyone who submitted work, all of our reviewers, all of the people sort of behind the scenes helping us out with this kind of stuff. Since I think for most of us, maybe not James, but at least for us, this was our first time running a workshop.
Yeah.
So if you have any feedback for us, any ideas, any thoughts about how we can make this better, if you're interested in getting involved, you know, feel free to come and talk to us about this during the demo session or email one of us. I believe our contact information may be up on the EXAG website.
It's still up on the EXAG website. You might have to scroll through things, but it's there.
And workshop proceedings will also be linked there as well shortly. So now feel free to go grab some coffee and snacks whenever they appear. And we'll resume here around 4 o'clock for demos or whenever people feel like playing.
And to the internet, unfortunately, we're not going to be able to stream that because I've only got one webcam. So thank you to everyone who's been in chat and everyone who's hung out and watched these videos. You all also mean a lot to us as well.
All right. Applause for the committee.